Tonight, we begin a journey to understand how big the universe might be and what may lie beyond what humans can see. Most people fall asleep inside a small personal world, inside the walls of a bedroom. But the truth is that you are falling asleep inside a universe that is enormous beyond imagination. The room is small, the world is large, but the universe is so vast that even the most powerful telescopes can only catch a tiny part of it. Tonight we walk through that doorway, not to overwhelm your mind, but to slow it, to ease it, and to allow it to drift along a calm current of knowledge and wonder. Scientists call the part of the universe we can see the observable universe. It is a bubble centered on Earth, not because Earth is special, but because light travels at a fixed speed, and we can only see as far as light has had time to reach us. This bubble is already enormous, stretching for billions of light years in every direction. Yet, everything inside this bubble is still only a small fraction of what exists. The true universe may be much larger, may be infinite, may be layered, may be connected to other regions we can never reach. As you listen, allow your mind to settle into the idea that you are lying in a calm pocket within a space that expands in all directions. There is no rush to understand every detail. The goal is not to analyze, but to rest inside the rhythm of distant facts. Think of yourself as floating, supported by the quiet gravity of night. We know the universe is expanding. Galaxies drift away from each other as space itself stretches. Imagine dots on a soft piece of fabric that is being pulled at the edges. The dots do not move on their own. It is the fabric that grows, carrying them with it. This is how galaxies behave. This is how our own Milky Way glides through space, held in place by gravity, yet carried outward by expansion. If you let this image form slowly, it becomes comforting. Everything is drifting in a gentle outward motion. There is no sharp edge, no wall, only space growing larger, softer, and quieter as you travel deeper into sleep. Scientists estimate that there are hundreds of billions of galaxies in the observable universe. Each galaxy holds hundreds of billions of stars. Many of those stars have planets. Some of those planets may have atmospheres, oceans, and surfaces lit by the gentle warmth of starlight. When you close your eyes, you are resting inside a universe filled with worlds you will never meet. Yet their light travels across space to reach the place where you lie now. Deep sleep begins when the mind has something steady, slow, and expansive to hold on to. The scale of the cosmos gives your thoughts permission to quiet down. The details of daily life become small compared to the calm, steady drift of galaxies moving across billions of years. This is why many people fall asleep more easily when they think about space. The universe offers perspective, and perspective offers rest. As your breathing remains slow, imagine yourself moving through space with no effort. There is no sound, only quiet. There is no wind, only emptiness. Space is not cold in the way air is cold. It is a vacuum, a silent bridge between stars. In the middle of that quiet, you drift. You are not falling. You are simply carried. In deep sleep research, scientists observe how the brain reacts when the mind imagines slow movement or gentle expansion. The brain waves enter a pattern that supports rest. Your thoughts become longer and smoother. This chapter, the doorway chapter, is designed to help your brain ease into that pattern. Now picture the observable universe again. Picture the bubble of space that light has revealed to us. Everything inside that bubble is already too large to understand in one lifetime. Yet everything beyond that bubble remains untouched by any telescope or instrument humans have built. You are standing at the edge of knowledge, not in a frightening way, but in a peaceful way. The unknown is calm. It is quiet. It is wide. As you rest here, let the idea settle. The universe is large, but your place in it is secure. You are connected to stars through the atoms in your body. The calcium in your bones was formed in ancient stellar explosions. The carbon in your cells came from the heart of a giant star that lived and died long before the Earth existed. When you lie down to sleep, you are returning to the same quiet field of energy that produced every atom you carry. This connection is not poetic, it is scientific. The universe is not outside you. You are a continuation of it. And as your mind softens, the boundary between your thoughts and the cosmos becomes lighter, thinner, easier to drift across. Let this chapter close gently. Breathe. Feel the weight of your body sink into your bed. Feel the slow widening of your awareness. You are safe, and you are ready to move deeper into the cosmos in the next chapter. The doorway is open. The night is calm. The universe waits. When we talk about the universe, we often picture a vast, dark space filled with stars. But the truth is far more structured and far more complex than a simple image of the night sky. In this chapter, we focus on the part of the universe that science can measure, map, and describe, a region known as the observable universe. As you settle into a comfortable position, let the smooth flow of these ideas guide your thoughts into a slow and steady rhythm, a rhythm that supports deep sleep and quiet reflection. The observable universe is defined by the distance that light has been able to travel since the beginning of time. Light moves at a constant speed, and because the universe has a finite age, there is a limit to how far light has reached. This creates a bubble around us, a sphere centered on the Earth, not because we occupy a special place, but because we observe the universe from our point of view. Every distant galaxy we see is a point where light began a journey billions of years ago, long before humans existed, long before Earth formed, long before the Milky Way took shape. The size of this bubble is enormous. The radius of the observable universe is about 46 billion light years. This means that light from the most distant objects we see has traveled for billions of years through expanding space. As space expands, the distance stretches even more, so the objects are now much farther away than the time their light spent traveling to us. This is one of the reasons the universe feels so huge. Time, distance, and expansion create a layered complexity that challenges the human mind, yet offers a calming sense of scale for anyone trying to fall asleep. Inside the observable universe are galaxies of every shape and size. Spiral galaxies like our Milky Way, elliptical galaxies that look like smooth, glowing spheres, and irregular galaxies that formed in chaotic environments. Each galaxy contains stars, planets, gas clouds, dust, and mysterious structures shaped by gravity. When scientists map these galaxies, they notice patterns. Galaxies are not scattered randomly. They form clusters and superclusters, giant strands and sheets of matter that weave across the cosmos like a web. This pattern is called the cosmic web. It resembles a vast, three-dimensional network where bright galaxies sit at intersections of invisible threads made of dark matter. Dark matter is one of the most important concepts in modern astronomy. It does not emit light, it does not absorb light, and it cannot be seen directly. Scientists know it exists because its gravity affects the motion of stars and galaxies. Imagine looking at a spinning galaxy. The stars on the outer edge move too quickly to be held in place by the visible mass alone. Something else must be adding gravity. That something is dark matter. It forms halos around galaxies and fills large regions of space, giving the universe structure and stability. As you listen, imagine dark matter as a silent framework, a supportive skeleton surrounding the cosmos. It is calm and steady, holding everything in place, shaping the universe quietly and predictably. In this way, the idea becomes soothing. Even in a universe so vast, there is structure, order, and balance. Along with dark matter, scientists study the light from distant objects to understand how the universe changes over time. When light from a distant galaxy stretches as space expands, it shifts toward the red end of the spectrum. This effect is called redshift. Higher redshift means greater distance and older light. By measuring redshift, astronomers build a timeline of the universe, seeing it not as a fixed picture, but as a story that unfolds across billions of years. As your breathing falls into a slow pattern, imagine this timeline as a long, smooth path stretching behind us. Each step backward takes us closer to the beginning of everything. When we look far enough, we see the faint afterglow of the Big Bang, a soft microwave radiation that fills all of space. This glow is called the cosmic microwave background. It is the oldest light we can detect, a snapshot of the universe when it was young, hot, and dense. To fall asleep while thinking about this light is to rest inside a picture drawn more than 13 billion years ago. The observable universe is not the whole universe. It is simply the part we can measure. The true size may be far larger, and possibly infinite. But the observable universe gives us the foundation we need. It is the measurable slice, the part that allows scientists to estimate the age of the cosmos, its temperature, its density, and its expansion rate. Through this slice, we build models that reach beyond it. This knowledge does not have to feel overwhelming. Instead, let it settle into your awareness slowly, like a gentle tide. The universe is large, but it is also steady. It follows laws of physics that remain constant. Gravity pulls, light travels, space expands, particles move, energy shifts. These rules hold everything together, and they allow you to rest without fear or confusion. The cosmos is vast, but it is consistent. Picture the observable universe one more time as a soft, glowing sphere around you. Inside it, billions of galaxies drift through space. Outside it, darkness stretches into regions we cannot see. This contrast feels calming, like falling asleep near a quiet boundary. You do not need to reach beyond it. You only need to drift through the calm understanding that science has given us. As this chapter comes to a close, allow your thoughts to soften. Let the image of galaxies and dark matter fade gently. Your breath stays slow. Your body feels heavy. The universe remains vast, steady, and quiet as you drift deeper into rest. When you are ready, the next chapter will guide you farther into the hidden structure of space. As you settle deeper into a comfortable state, this chapter guides you through the quiet and intricate architecture that shapes the universe. Space may look empty when we glance at the night sky, but modern science shows that space is structured, layered, and filled with invisible forces that give the cosmos its shape. Understanding this hidden architecture is less about memorizing details and more about relaxing into the idea that the universe has an inner order, a gentle framework that supports everything within it. Imagine space not as a simple void, but as a flexible fabric that stretches and curves. Scientists call this fabric space-time. It behaves like a smooth surface that can bend under the weight of stars and galaxies. When a massive object sits in space-time, it creates a curve, and smaller objects follow that curve. This is what we experience as gravity. It is not a force that pulls, but a path that bends. As you picture this, let your mind drift across the quiet simplicity of this idea. Space bends, objects move, and the universe follows its natural rhythm. These curves in space-time form the foundation of the universe. Every orbit, every falling object, every drifting galaxy follows a path shaped by unseen contours. When we look at images of galaxies spiraling around their centers, we are watching matter respond to these gentle curves. It is a slow dance, billions of years long, guided by the hidden structure beneath everything. Let this idea feel calm to you. Just as your body follows the steady pull of Earth, stars follow the arcs of space-time across the vastness of the cosmos. Within this architecture exists another important layer: dark matter. In the last chapter, we touched on its presence, but here we consider how it shapes the universe on a larger scale. Dark matter forms vast halos around galaxies. These halos extend far beyond the visible stars, creating a stable environment that keeps galaxies together. Without dark matter, spiral galaxies would fly apart. With dark matter, they remain steady for billions of years. Think of dark matter as a soft, invisible cushion that surrounds galaxies, holding them in place without sound or movement. Now picture the cosmic web, the largest structure humans have ever mapped. It stretches across billions of light years. It is made of filaments where galaxies cluster together, and between these filaments lie enormous cosmic voids. These voids are not completely empty, but they contain far fewer galaxies than the dense regions of the web. The pattern looks like a vast three-dimensional network, or a neural system floating in space. As you imagine it, let the slow branching lines flow across your awareness like gentle currents. This web did not form by accident. It is shaped by gravity, expansion, and the distribution of dark matter. Early in the universe, tiny fluctuations in density caused matter to gather in certain places. Over billions of years, these small differences grew into the structures we see today. Filaments, clusters, and superclusters emerged from the quiet pull of gravity acting across unimaginable distances. This slow formation mirrors the way your thoughts settle at night. Small patterns become larger shapes. Quiet details become steady foundations. Another key part of the universe is dark energy, a mysterious form of energy that drives the expansion of space. While dark matter pulls things together, dark energy pushes space outward. Scientists do not yet know what dark energy is, but they can measure its effects. It accelerates the expansion of the universe, making distant galaxies drift away faster over time. Imagine dark energy as a gentle pressure that stretches the fabric of space. It does not create chaos, it creates room. More space, more distance, more quiet between galaxies. Together, dark matter and dark energy form the majority of the universe. The stars, planets, and gas that we see make up only a small fraction of all that exists. Most of the cosmos is unseen, yet its influence is steady and predictable. Let that thought feel comforting. There is more beyond what we see, and it behaves in calm and consistent ways. The hidden architecture is not wild or unpredictable. It follows natural laws that guide the entire universe with soft precision. Now, imagine yourself floating near one of the filaments of the cosmic web. You drift in a quiet region between galaxies. In the distance, you see clusters of glowing points, each point a galaxy filled with stars. Around you is the invisible structure of dark matter, the gentle stretching of space-time, and the soft pressure of dark energy. Everything around you is quiet, steady, balanced. The architecture of the cosmos supports your drift, offering you a place to rest in thought. When scientists observe the universe, they see this architecture through patterns in light, motion, and temperature. They map the shapes of filaments. They study how galaxies move. They measure the expansion of space. These measurements reveal a universe that is structured on every scale. From atoms to clusters of galaxies, everything follows the same natural rules. This is part of why the night sky feels peaceful. We sense the stability of the cosmos, even if we do not consciously think about it. Settle into a calm position. Let your breath fall into an even pattern, and imagine yourself drifting deeper into the quiet rhythm of the universe. In this chapter, we focus on the speed of light and the boundaries it creates. These boundaries are not walls. They are gentle limits that help shape what we can know. Understanding these limits brings a peaceful sense of order to the cosmos, a feeling that everything has a rhythm, including discovery itself. Light moves faster than anything else in the universe. Its speed is constant, about 186,000 miles per second. Nothing travels faster. Nothing carries information more quickly. When we look at a star, we are seeing light that left that star years ago. When we look at a distant galaxy, we are seeing light that began its journey billions of years ago. The night sky is a map of the past. Every point of light is a message sent long before this moment. As you think about this, let your mind drift into the slow flow of time that stretches behind every distant glow. Because light has a maximum speed, we cannot see the entire universe at once. We can only see the regions where light has had enough time to reach us. This creates the observable universe. Beyond that distance, light has not yet arrived, so those regions remain hidden. This is not a barrier designed to block us. It is a natural limit created by the age of the universe and the steady speed of light. In this way, the boundary feels gentle, like the edge of a calm lake where water disappears into darkness. The speed of light also shapes how we study the cosmos. When scientists observe distant galaxies, they are looking back in time. The farther the object, the older the light. This makes the universe a layered record of its own history. Nearby galaxies show the present state of space, while distant galaxies reveal earlier eras. The oldest light we can detect, the cosmic microwave background, shows the universe as it was when it was young, dense, and filled with soft radiation. This light comes from more than 13 billion years in the past. It is a faint glow that carries the earliest messages we can read. As your thoughts move slowly across this idea, imagine the universe as a long corridor of time. You stand in the present, and light fills the corridor from all directions. Some light comes from nearby, some from very far away. Each source tells a different part of the story, and all of it arrives at the speed of light. There is no rush. There is no pressure. The universe communicates in a slow, steady rhythm that helps your mind ease into rest. Scientists also study how space itself expands. When space stretches, light stretches with it. This causes redshift, the increase in wavelength that happens when distant galaxies move away from us. Higher redshift means the light has traveled farther and has been stretched more. By measuring redshift, astronomers learn how fast galaxies move and how the expansion of the universe changes over time. This method shows that the universe is not only expanding, it is expanding faster now than it did in the past. This discovery leads to the idea of dark energy, a gentle pressure that pushes space outward. The speed of light creates another limit known as the cosmic horizon. This horizon marks the farthest distance from which light can ever reach us during the entire lifetime of the universe. Anything beyond this horizon is permanently out of reach. Its light will never arrive. No telescope will ever see it. Yet this is not a frightening limit. In deep sleep, it becomes a calming one. It reminds us that the universe is vast beyond measure, and that there will always be more than we can observe. This sense of mystery encourages the mind to relax, to release the need to know everything, and to drift into a peaceful acceptance of the unknown. Imagine standing near the cosmic horizon. You look outward into a region where light has not yet traveled to you. It is quiet, smooth, and wide. Beyond it may lie billions of galaxies, or entirely new structures we cannot imagine. The universe continues outward, whether we see it or not. This thought creates a gentle space in your awareness, a space where curiosity and calm coexist. You do not need to reach beyond the horizon. You only need to rest in the quiet understanding that the horizon exists because the universe has a natural pace. Even within these limits, light allows us to explore an enormous part of the cosmos. Telescopes that capture visible light, infrared light, ultraviolet light, and other wavelengths give us different views of the same structures. Light waves reveal gas clouds, star clusters, black holes, and distant galaxies. Each wavelength adds detail to the map we build. The universe speaks in many frequencies, and light carries each one at the same steady speed. As you listen, imagine light traveling across billions of miles, through calm stretches of empty space, through regions filled with galaxies, through cosmic voids, and across the delicate structure of the cosmic web. It arrives with no sound, no pressure, no haste. It brings the story of the universe to us with quiet precision. This quiet flow mirrors the rhythm of your breath. Slow, steady, continuous. Light speed sets the pace of discovery. It shapes our understanding of distance and time. It defines what we can observe and what remains beyond reach. These limits are not obstacles. They are invitations to rest within the boundaries of what is known and to accept the peace of what is unknown. As this chapter comes to an end, let your thoughts soften once more. Feel the calm weight of your body sinking into rest. Light continues to travel across the universe, slow and steady. You do not need to chase it. You only need to drift with the quiet rhythm it provides. The next chapter will guide you into the dark universe, where unseen matter and energy form the majority of what exists. As you settle deeper into rest, this chapter guides you into one of the most mysterious parts of the cosmos, the dark universe. Most of what exists is not the matter we see in stars and planets. Most of the universe is made of dark matter and dark energy, two unseen components that shape everything. This chapter will move slowly, allowing each idea to flow through your thoughts like a quiet current that supports deep sleep. Begin by imagining the universe as a vast ocean. The stars and galaxies we see are like glowing islands floating on the surface. They catch our attention because they shine, but they are only a small part of the whole picture. Beneath the surface lies a deep structure that cannot be seen with light. This deeper structure is dark matter. It forms the hidden framework of the universe. It surrounds galaxies. It fills space between them. It holds everything together with gravity. Without dark matter, the universe would look very different. Dark matter does not emit light. It does not reflect light. It does not absorb light. Scientists cannot see it directly. They only know it exists because of the way it influences the motion of stars and galaxies. In spiral galaxies, stars move faster than they should if only visible matter were present. Something else must be adding gravity. That something is dark matter. It forms large halos around galaxies, reaching far beyond the outer stars. These halos give galaxies their stability and allow them to keep their shape over billions of years. Imagine yourself drifting through one of these halos. There is no sound, no light, no wind, only a quiet presence, a steady field of gravity that shapes the path of everything within it. As you float, the invisibility of dark matter does not feel threatening. It feels calm and steady, like a gentle hand guiding the motion of stars along predictable paths. Dark matter is not chaotic. It is stable. It is consistent. It is a silent partner in the formation of every galaxy. Now let your thoughts shift to the other major component of the dark universe: dark energy. While dark matter pulls things together, dark energy pushes space outward. It is a smooth energy that fills all of space and drives the expansion of the universe. When scientists discovered that the universe is expanding faster today than in the past, they realized something must be causing this acceleration. That something is dark energy. Dark energy is even more mysterious than dark matter. It has no known particles. It has no measurable structure. It does not gather in clusters or halos. Instead, it spreads evenly across all of space, like a quiet pressure that stretches the fabric of the cosmos. Imagine a soft force that expands the space between galaxies without disturbing the galaxies themselves. This force does not rush. It does not pulse. It acts smoothly, steadily, quietly. The combination of dark matter and dark energy makes up most of the universe. Ordinary matter, the matter that forms atoms, planets, stars, and people, makes up only a small slice. This fact surprises many people, but it also creates a feeling of peace. The universe is largely shaped by components that do not burn, collide, or create noise. The unseen parts of the cosmos are calm. Scientists study the dark universe through indirect measurements. They look at how galaxies move. They measure the expansion rate of space. They study patterns in the cosmic microwave background. All of these observations point to the same conclusion. The universe is filled with invisible matter that adds gravity and invisible energy that pushes space outward. Together, they shape everything. As your breathing slows, imagine the interplay of these two forces. Dark matter pulls. Dark energy expands. One gathers. One stretches. They work in balance across billions of years. Their interaction creates the large-scale structure of the cosmos. Filaments, clusters, voids, galaxies drifting along invisible paths. This balance is not violent. It is slow, smooth, and measured. Picture the cosmic web again. Its filaments glow with galaxies, but the web itself is supported by dark matter. Now imagine that same web expanding gently over time, carried by dark energy. The shapes remain connected. The distances grow. The universe becomes more spacious, more open, more quiet. This slow expansion mirrors the way your thoughts open as you fall deeper into sleep. Space grows. The mind softens. Awareness drifts. Many people wonder what dark matter and dark energy are made of. Scientists do not yet know. They search for particles. They build experiments underground. They observe distant light for signs of new physics. But the answers remain hidden. The dark universe keeps its secrets for now. Instead of bringing frustration, this mystery can bring calm. Not everything must be known. Some parts of the universe remain quiet and beyond reach, allowing the mind to rest in the gentle space of not knowing. As you drift deeper, think of dark matter as the supportive bones of the cosmos, and dark energy as the soft breath that fills the universe with motion. One shapes, one expands. Together, they create a universe that is larger than any image we can see. This vastness is not overwhelming. It is peaceful. It gives your thoughts room to release tension and drift toward rest. As you rest deeper into the quiet of the night, this chapter opens the door to one of the most intriguing ideas in modern cosmology. The possibility that our universe may not be the only one. Scientists call this idea the multiverse. It is not a single theory, but a collection of hypotheses that suggest there could be other universes beyond our own. These ideas are not meant to excite the mind, but to give it space, to stretch awareness in a calm and steady way, to let you drift through possibilities that are vast and quiet. Begin by imagining our universe as a single bubble floating in a much larger cosmic space. This bubble contains everything we can observe: galaxies, stars, planets, dark matter, dark energy. All of it is inside one expanding sphere. Now, imagine that this sphere is just one bubble among many. Other bubbles may float nearby or far away. Some may be larger. Some may be smaller. Some may expand faster. Some may contain entirely different physical laws. This picture is one of the simplest ways to understand the multiverse. Scientists explore the multiverse because certain questions about our universe remain difficult to explain. For example, the values of our physical constants, such as the speed of light and the strength of gravity, seem finely tuned for the existence of matter and life. If these values were slightly different, stars might not form. Atoms might not bind. The universe could collapse or expand too quickly. The multiverse hypothesis suggests that many universes exist with different constants, and we simply live in one where the conditions allow structures to form. As you breathe slowly, let this idea expand gently across your awareness. You are not imagining chaos. You are imagining possibility. A quiet landscape where many universes float like soft lights in an endless space. One version of the multiverse comes from inflation theory. Early in the history of the universe, space expanded extremely quickly. This rapid expansion may have occurred in different regions at different times. Some regions may have stopped expanding and formed universes like ours. Other regions may have continued expanding, creating new pockets of space that become their own universes. In this picture, our universe is one region among countless others, each with its own timeline. Another version comes from quantum mechanics. At the smallest scales, particles do not have fixed states. They exist in many possible states until they interact with something. Some physicists propose that each possibility becomes real in a different branch of the universe. This idea is known as the many worlds interpretation. It suggests that every possible outcome of a quantum event exists in a separate universe. In this view, reality is not single, but branching. Each moment splits into many paths. Though these ideas may seem complex, let them flow past your awareness like gentle waves. You do not need to hold every detail. Simply rest in the feeling that the universe may be part of something larger, and that this larger reality is calm and spacious. Another multiverse idea arises from string theory. String theory proposes that particles are tiny, vibrating strings, and that additional dimensions may exist beyond the 3 dimensions we experience. These extra dimensions may contain entire universes. Some models even suggest that universes can form when higher dimensional surfaces collide or separate. These universes might be similar to ours or entirely different. As you drift in thought, imagine yourself floating in a smooth space where universes slide past one another like silent sheets. No noise, no pressure, just gentle motion. Each universe moves on its own trajectory, guided by physical laws that shape its structure. The multiverse is not proven. It is a set of hypotheses built from mathematics and physical theories. Some scientists support it, others question it. Many agree that it offers elegant explanations for difficult questions, but it remains beyond direct observation. For now, it is a possibility that gives us perspective, a reminder that the universe may be far larger than we can measure. Even though we cannot see other universes, the idea helps us understand our own. It reminds us that space can be more complex than it appears. It shows that the laws of physics may not be universal. It suggests that our universe may be one example among many. This perspective brings a soft sense of humility and calm. We do not need to know everything. We can rest in the possibility that our universe belongs to a much larger reality. As your breathing deepens, imagine the multiverse as a quiet field of bubbles stretching into the distance. Each bubble contains a cosmos with its own galaxies and energies. Some bubbles drift closer, some drift farther. You rest inside one bubble, safe and still, surrounded by infinite potential. The vastness does not overwhelm you. It supports you. It gives your mind room to release tension and drift toward deep sleep. Settle deeper into your breath and let your mind drift into a smooth and open space. This chapter guides you into one of the most important ideas in cosmology: cosmic inflation. Inflation describes a moment in the early universe when space expanded at an extraordinary rate. This expansion happened so quickly that regions of space were stretched far beyond one another almost instantly. Understanding inflation helps us understand why the universe looks the way it does today, and why it may extend far beyond the parts we can observe. Imagine the universe at its beginning. It was not filled with stars or galaxies or planets. It was filled with energy and particles in a dense and hot state. Then, something remarkable occurred. For a tiny fraction of a second, space expanded at a speed faster than anything we can easily imagine. During this moment of inflation, distances grew by enormous factors. Regions that were once close became separated by great stretches of space. This expansion smoothed out the early universe, creating a nearly uniform background from which galaxies would later form. As you breathe slowly, imagine space stretching like a soft fabric. The stretching happens smoothly, silently, evenly. There is no sound. There is no pressure. There is only expansion that moves across the young universe. This image helps your mind settle into the idea that the universe has been expanding from its earliest moments and continues to expand even now. After the brief period of inflation ended, the universe continued to expand at a slower pace. Over time, matter gathered into clumps. These clumps became stars and galaxies. Gravity shaped them into the large-scale structures we see today. But the effects of inflation remain. They set the initial conditions that allowed the cosmic web to form in a smooth and balanced pattern. Inflation also explains why the observable universe looks uniform in temperature and structure. Light from opposite sides of the observable universe appears to come from regions that were once close before inflation stretched them apart. This uniformity gives scientists confidence that inflation is a strong explanation for the early behavior of space. Now imagine that inflation did not happen only once. Some models suggest that inflation may occur repeatedly in different regions of space, a process known as eternal inflation. In this picture, our universe is one pocket where inflation slowed down. Other pockets may exist where inflation continues or has stopped at different times. These pockets can become independent universes. This idea connects cosmic inflation to the multiverse. Many universes may arise from endless cycles of inflation, each expanding and evolving separately. You do not need to hold every detail. Let the idea float gently. Space expands. Inflation stretches regions apart. New pockets of space may form. The universe becomes a vast landscape of expanding regions. This image is calm and wide. It allows your thoughts to drift like particles carried by a gentle current. Inflation also gives scientists clues about the shape of the universe. Observations suggest that the universe is nearly flat. In geometry, flat does not mean small. It means that space is not curved dramatically on large scales. A flat universe can still be infinite. Inflation stretches space so much that any curvature becomes nearly impossible to detect. This creates the possibility that the universe extends endlessly beyond what we can observe. Think of yourself lying on a large plain that stretches far beyond the horizon. The ground beneath you feels flat and stable. The horizon feels distant. You cannot see what lies beyond it, but you know the plain continues. This is how the universe behaves when shaped by inflation. The part we can see is only a small region in a far larger expanse. Cosmic inflation also predicts slight variations in the early universe. These variations are tiny differences in density that later grew into galaxies and clusters. When scientists measure the cosmic microwave background, they see a pattern of small fluctuations. These fluctuations align with the predictions of inflation. They provide a gentle map of the earliest seeds of structure, a map that shows how galaxies formed from small ripples in the young universe. As you drift deeper into rest, imagine these ripples spreading across the early universe. They form patterns. They shape the future. They outline the places where matter gathers. The movement is slow, smooth, predictable. These ripples are like soft waves on a calm sea. They guide the long evolution of space and time. The concept of endless expansion adds another layer to this calm picture. Today, the universe continues to expand. Distant galaxies move away from us. Space grows. Dark energy accelerates this growth. Every moment, the universe becomes slightly larger. The expansion is not violent. It is gentle, silent, steady. It gives the cosmos a sense of flow, a movement that continues even as you sleep. Imagine yourself floating far from any galaxy. You see faint points of light in the distance. Space around you opens slowly. the distance between galaxies increases. Yet everything remains calm and balanced. Expansion does not disturb the internal structure of galaxies. It simply creates more room between them. This room feels peaceful, like an open field that gives the mind space to rest. As this chapter comes to a close, let the image of inflation and expansion settle gently into your awareness. Space grows, the universe stretches, new possibilities unfold. The cosmos is larger than the parts we can observe. It may extend endlessly. It may contain pockets beyond our reach. This vastness is not overwhelming. It is spacious. It supports deep rest. In the next chapter, we explore the edges we cannot see and the limits that define our cosmic horizon. Let your breath fall into a steady rhythm as we move into one of the quietest and most mysterious ideas in cosmology. The idea of the unseen edges of the universe. These edges are not physical walls. They are horizons created by time, light, and expansion. They mark the limits of what we can observe, not the limits of what exists. As you listen, let these boundaries feel soft and open, like distant hills hidden by fog, always present but never sharp. When scientists talk about edges, they refer to the observable universe. This region is defined by the distance light has traveled since the beginning of time. Beyond that distance lies a vast expanse of space that remains hidden because its light has not reached us. We call this boundary the cosmic light horizon. It is not a fixed surface. It expands as time passes. Every moment adds a small layer to the region we can observe. Yet the horizon always remains far away. Imagine standing on a wide plain under a soft sky. The horizon is the farthest point you can see. You know the land continues beyond it. You know the sky stretches farther, but your eyes cannot reach those distant regions. This is similar to how the cosmic horizon works. It marks the farthest distance from which light has had time to reach us. Beyond it, the universe continues in directions we cannot see. There is another kind of horizon created by the expansion of the universe. As space stretches, distant galaxies move away from us. Some galaxies move away faster than the speed of light because space itself expands. This does not break the laws of physics. It simply means that the fabric of space grows, carrying galaxies with it. When galaxies move away faster than light can travel, their light can no longer reach us. These galaxies slip beyond what scientists call the cosmic event horizon. Imagine a small boat drifting on a calm ocean. The water expands around it. Islands in the distance drift farther away. Soon they move so far that their details fade. Eventually, they disappear completely into the haze. They still exist. They are still part of the ocean, but they have moved beyond what you can observe. This is how the event horizon behaves. It slowly moves galaxies out of view, not by pushing them, but by expanding the space between us. As your breath remains slow and smooth, picture the universe with these two horizons. The light horizon marks what has had time to reach us. The event horizon marks what will never reach us. Between them lies the observable universe, a region full of galaxies, stars, and the cosmic web. Beyond them lies a vast reality that remains unseen and possibly endless. These unseen edges give scientists valuable insight. They show that the universe is far larger than what we can measure. They remind us that the part we study is a fraction of a much bigger structure. They also help scientists estimate when galaxies will drift beyond reach. Over billions of years, more and more galaxies will cross the event horizon. The universe will appear emptier from our point of view, even though the galaxies still exist beyond our sight. This idea may sound lonely, but it is actually peaceful. The universe evolves slowly. The expansion happens over immense timescales. Nothing changes suddenly. The horizons shift gently. The unseen edges grow quietly. This slow motion mirrors the rhythm of deep sleep. A steady drift, a gradual separation, a sense of space opening. Scientists also study the shape of the universe to understand these edges. Observations show that the universe is nearly flat. In a flat universe, straight lines remain straight over large distances. This means space may extend indefinitely. If so, the unseen regions are not smaller or simpler than the observable universe. They may contain countless more galaxies, clusters, and structures beyond anything we have observed. Imagine yourself floating at the center of a calm sphere. This sphere is the observable universe. Its boundary is the light horizon. Outside the sphere lies an ocean of space that continues without end. More galaxies, more clusters, more cosmic web. You cannot see these regions. You cannot measure them, but you can imagine them as part of a quiet and open landscape. Some scientists estimate that the true universe may be many times larger than the observable part. Not 2 times, not 10 times. Some models suggest it could be trillions of times larger. This number is so great that it becomes abstract. Instead of trying to visualize the full size, let the concept become soft. Infinite space, endless regions, a universe that continues far beyond what light can reveal. These unseen edges do not limit human understanding. They guide it. They show us where knowledge ends and curiosity begins. They remind us that the universe is filled with possibilities beyond what we can measure. This reminder is calming. It invites the mind to release the need for complete understanding. It allows you to drift into rest with the comfort that some mysteries are gentle and welcoming. As this chapter comes to a close, picture the horizon of the universe spreading outward in all directions. It expands slowly and silently. You rest within it, safe and still. The unseen edges are not barriers. They are gentle boundaries that open into a larger reality. In the next chapter, we explore the possibility of parallel realities and how they shape our understanding of what lies beyond the horizon. Let your breath fall into a calm and steady rhythm as we drift into a new idea: parallel realities. These models describe the possibility that our universe exists alongside many others, not separated by distance but by different layers of reality. These ideas are not presented to excite the mind. They are offered as quiet possibilities that open space inside your thoughts, giving you room to rest as you imagine a wider and softer cosmos. Begin by picturing our universe as a single sheet in a vast stack of sheets. Each sheet represents a different reality. Some sheets may be similar to ours. Some may be different. Some may hold different forms of matter or different patterns of physics. These sheets do not collide. They float parallel to one another, separated by dimensions we cannot see or measure. This simple image forms the basis of certain parallel reality models. One of the most discussed models comes from quantum theory. At the smallest scales, particles do not follow fixed paths. They behave in many possible ways until they interact with something. Some physicists suggest that each possibility becomes real in a different branch of reality. This idea creates a calm landscape of parallel universes that branch from every event. Each branch follows a different path. Over time, the branches form a wide tree of realities. As you breathe slowly, imagine these branches spreading outward like soft lines drawn across a quiet field. Each line represents a version of the universe shaped by different outcomes. None of the branches collide. None of them interfere. They expand gently and smoothly, like roots growing through soft soil. Another parallel reality model comes from string theory. If the universe contains more spatial dimensions than the ones we experience, those dimensions may hold entire universes within them. In this view, parallel realities may not be distant. They may be close, existing just beyond the limits of our perception. Our universe might be one surface in a higher dimensional space. Other surfaces may float nearby, each with its own properties. Imagine yourself drifting through a calm space where these surfaces glide silently. Each surface is wide. Each surface is steady. They do not touch, but they share the same larger environment. This image provides a gentle sense of depth, like falling asleep in a room with soft layers of quiet air surrounding you. There is also the idea of bubble universes, where each universe forms as a bubble in a larger, inflating space. These bubbles may exist side by side, expanding and moving, yet never interacting. Each bubble follows its own timeline. Each bubble forms its own galaxies. Each bubble carries its own laws of physics. Scientists explore these models because they help explain the fine-tuning of our universe. If many universes exist, then the conditions in each one can vary widely. Let your thoughts drift into this picture. A wide ocean of bubbles expanding through a calm and endless field. Our bubble is one among many. The other bubbles do not disturb us. They simply drift. This image supports a gentle sense of scale that allows the mind to relax. Some models suggest that these parallel realities may sometimes influence each other in subtle ways, not through collisions or contact, but through small effects that appear in the behavior of particles or energy. These ideas remain speculative. Scientists continue to explore them. The possibilities remind us that reality may be more layered than we imagine. As you listen, allow these possibilities to flow without effort. Your mind does not need to solve them. It only needs to observe the calm that comes from imagining a universe with many layers. Parallel realities do not replace our universe. They expand it. They show that the cosmos may be part of a wider structure that is smooth, quiet, and beyond direct observation. These models also remind us that human perspective is limited. We see only a single version of reality. We experience one timeline. We follow one path. Yet physics suggests that more may exist. This sense of vastness does not create anxiety. It creates peace. It allows the mind to let go of daily details and drift into a deeper sense of space. Imagine yourself floating between these layers. You do not move through them. You simply rest in the awareness that they exist. The space between realities is gentle and silent. It offers room for thought to stretch and soften. The more you imagine, the more your awareness becomes light and open. Parallel reality models also help scientists question what it means for something to exist. If many versions of reality unfold at once, then the universe is not defined by a single timeline. It becomes a collection of possibilities, a wide field of outcomes that extend across different layers. This view supports a calm understanding that reality is broader than our senses can detect. In the next chapter, we move from large-scale ideas to the smallest scales of nature, exploring the quantum layer of the cosmos and how it shapes everything we see. Let your breathing settle into a soft and steady flow as we drift inward. Through this chapter, we move from the vast scale of galaxies and horizons to the smallest layer of nature, the quantum layer. This is the foundation beneath everything. It is the realm where particles flicker into existence, where energy shifts in quiet patterns, and where the building blocks of the universe behave in ways that feel strange but predictable. As we explore this layer, let each idea settle like a gentle ripple in a calm pool. The quantum world is different from the world we see. In our everyday experience, objects have fixed positions. They move along clear paths. They follow predictable rules. But at the smallest scales, particles do not behave this way. They act in ways that seem uncertain. They move in patterns defined by probability. They shift between states. They appear and disappear. They follow rules that feel soft and fluid rather than firm and solid. Imagine looking at a calm sheet of water. From far away, the surface looks smooth. But as you move closer, you see tiny ripples. These ripples represent the quantum layer. They are small, gentle, constant. They give structure and texture to the water. In the universe, these ripples arise from quantum fields that fill all of space. Every particle is an excitation of one of these fields. Every bit of matter and every flash of light is the result of the quantum layer beneath everything. One of the guiding principles of quantum physics is uncertainty. This does not mean chaos. It means that certain pairs of properties cannot be known with perfect accuracy at the same time. For example, the exact position and the exact momentum of a particle cannot be measured together. This uncertainty allows particles to behave like waves and like particles at the same time. They spread out. They interfere. They blend. These behaviors create a soft and flowing picture of reality. As you breathe slowly, imagine particles drifting in smooth waves. They shift between possibilities. They settle into patterns only when measured. Between measurements, they exist in a calm cloud of potential. This image mirrors the feeling of drifting toward deep sleep. When thoughts soften and boundaries fade, the mind no longer holds sharp edges. It settles into a quiet field of possibilities, much like particles in the quantum layer. Another idea in quantum physics is entanglement. When two particles become entangled, their states become linked. No matter how far apart they move, their connection remains. A change in one particle relates to a change in the other. This connection does not involve communication. It is simply the way the quantum layer works. It creates relationships that stretch across space. Imagine two tiny lights drifting far apart in a wide field. Even as the distance grows, they remain connected in a silent and gentle way. This connection is not a force. It is a property of the underlying quantum field. It reminds us that the universe is woven together, even at the smallest scales. As you drift into deeper rest, imagine these connections flowing through space like quiet strands of light. Quantum physics also introduces the idea of vacuum fluctuations. Even in empty space, fields shift and ripple. Tiny particles appear and disappear. Energy flickers in and out of existence. This activity is not loud or violent. It is soft and constant. The vacuum is not empty. It is a quiet sea of motion that supports everything above it. Imagine yourself floating above this sea. The motion beneath you is gentle. You cannot feel it. You cannot see it. But it supports every atom in your body and every star in the sky. The quantum layer gives rise to all the structures in the universe. It is the deep foundation beneath galaxies, planets, and life. This layer also shapes the behavior of atoms. Electrons move in probability clouds around the nucleus. Their positions are not fixed. Their paths are not simple loops. They form regions of space where they are likely to be found. These shapes create the structure of atoms and molecules. They allow matter to form solids, liquids, and gases. They allow life to develop. Every breath you take involves quantum rules. Every heartbeat relies on the behavior of particles shaped by these subtle patterns. As your mind relaxes, imagine atoms settling into calm patterns. Electrons drift in smooth clouds. Nuclei vibrate gently. These motions happen constantly within your body and within everything around you. The quantum layer supports the rhythm of life and the quiet structure of matter. Quantum fields also help scientists understand energy and space. Theories that combine quantum physics with strong gravitational fields suggest that space itself may be built from tiny units. These units may behave like grains or nodes that form the fabric of space-time. This idea is still developing, but it offers a peaceful way to picture the universe. Space is not empty. It is structured. It has texture. It rises from the quantum layer like a woven fabric. As you picture this fabric, imagine it stretching beneath you as you rest. It is smooth. It is quiet. It carries the weight of stars and galaxies. It supports your body. It links everything through gentle patterns of energy. The quantum layer may also help explain the mysteries of dark energy and dark matter. Some theories suggest that vacuum energy may contribute to the expansion of space. Others suggest that particles not yet discovered may form dark matter. All of these ideas grow from the quantum foundation that fills the universe. Let your breath fall into a soft and steady pattern as we turn our attention to the oldest light in the universe. This chapter guides you into a calm understanding of ancient signals that have traveled across billions of years to reach us. These signals carry the history of the cosmos. They allow us to look back to a time long before stars and galaxies existed. As you listen, imagine these signals drifting through space like gentle waves, slow and steady, bringing quiet stories from the distant past. The oldest light we can observe is called the cosmic microwave background. This light fills the universe. It comes from a time when the cosmos was young, dense, and hot. Before this light was released, the universe was filled with charged particles that scattered photons in all directions. Light could not travel freely. It was trapped in a glowing fog of particles. But as the universe expanded and cooled, atoms formed. Once atoms formed, light could move through space without constant scattering. The fog lifted. The first free light began its long journey. Imagine this moment like a soft sunrise across the early universe, a glow spreading outward, a quiet release of energy. This glow is not bright to us now. It has stretched as the universe expanded. Its wavelength has grown longer. It has cooled to a gentle microwave signal. This signal reaches Earth from every direction, creating a calm and uniform background that scientists can measure with great precision. As your breathing remains steady, imagine this ancient light moving through space for more than 13 billion years. It passes through galaxies. It moves across voids. It drifts silently along the cosmic web. It carries small variations in temperature and density. These variations are tiny. They are gentle ripples that mark differences in the early universe. But these ripples became the seeds of all future structure: galaxies, clusters, stars, planets, life. Everything began from these faint imprints recorded in ancient light. Scientists study this light with satellites and sensitive detectors. They map the small variations across the sky. These maps look like soft patterns, gently shifting in color and temperature. The patterns reveal how the universe expanded. They show the amount of dark matter and dark energy. They confirm the predictions of cosmic inflation. Ancient light becomes a guide to the earliest moments of time. Imagine yourself floating in a quiet space where this light surrounds you. It is not bright. It is not warm. It is a soft presence that carries information about a time before galaxies formed. It is a reminder that the universe has a memory, a calm and quiet memory preserved across billions of years. In addition to the cosmic microwave background, the universe carries other ancient signals. Some come from the first stars. These stars formed when the universe was still young and dark. Before they ignited, the cosmos contained only hydrogen and helium. There were no heavy elements. When the first stars formed, they produced intense light that transformed the surrounding space. This period is called the Epoch of Reionization. It marks the time when starlight began to travel freely again. Imagine the first stars shining across the darkness. Their light spreads outward, creating spheres of warm gas. These spheres grow. They merge. They brighten the early universe. This light does not reach us directly in visible form, but scientists measure its effects through waves of hydrogen and through subtle distortions in the cosmic microwave background. These signals tell us when the first stars formed and how they changed the cosmos. Another form of ancient signal comes from gravitational waves. These waves are ripples in the fabric of space-time. They are produced by massive events such as merging black holes or neutron stars. Some theories suggest that inflation itself may have created gravitational waves in the earliest moments of time. If detected, these waves would carry information from before the cosmic microwave background. They would be the oldest signals we could ever observe. Imagine space-time as a calm pond. A stone falls into the water. Ripples spread outward. Gravitational waves act like those ripples. They travel across space at the speed of light. They pass through galaxies and stars. They reach Earth with incredibly small amplitudes. Scientists use sensitive detectors to measure these tiny ripples. These measurements reveal information about massive events in the distant past. As your mind relaxes, imagine these waves moving through the cosmos. They are silent. They carry the memory of ancient events. They remind us that space is not empty. It is a dynamic fabric that responds to energy and motion. Ancient light and ancient waves give scientists a way to study time itself. Each signal carries information from a different era. When combined, they create a timeline of the universe that stretches from the earliest seconds to the present moment. This timeline is smooth. It is continuous. It offers a sense of order and calm. Think of the universe as a long story written in waves of light and energy. Some chapters are bright, some are faint, some are recorded in patterns of radiation. Others are written in tiny ripples across space-time. Together, they form a quiet record of everything that has happened. As this chapter comes to a close, imagine ancient light filling the space around you. Soft, even, steady. It carries the calm memory of the early universe. you rest within that memory, safe and still. In the next chapter, we explore the energy fields that may extend beyond the known universe and shape its hidden regions. Let your breath settle into a slow and comfortable pattern as we drift into a subtle idea that stretches beyond the familiar borders of the cosmos. The universe we observe is shaped by energy fields that fill space and guide the motion of matter. These fields include electromagnetic fields, gravitational fields, and quantum fields. But some theories suggest that additional energy fields may exist beyond our observable universe. These fields may shape regions we cannot see and may influence the structure of space itself. As we explore these possibilities, let each idea move through your thoughts like a soft current. Begin by imagining space as a wide and gentle field. This field is not empty. It contains energy that shifts quietly. Even in empty space, quantum fields vibrate. They create small fluctuations that ripple through the vacuum. These fluctuations give rise to particles and forms of energy that shape the universe at every scale. Now expand this picture. Imagine that the fields we know may be only part of a larger set of fields that extend beyond our observable region. Some theories propose that hidden energy fields interact with dark matter. These fields may guide the motion of dark matter or influence how it gathers. Dark matter does not emit or absorb light. It interacts through gravity, but it may also respond to fields that we cannot detect. These fields could exist in regions of space much farther than the reach of our telescopes. Their presence would be subtle. Their influence would be slow and quiet. As your breathing remains steady, imagine these hidden fields as gentle layers that overlap the universe. They do not create noise. They do not disturb the calm of space. They form soft gradients of energy that guide the structure of matter. In the distant regions beyond the observable universe, these gradients may shape clusters and filaments. They may help define the large-scale architecture of the cosmos. Another idea comes from theories of extra dimensions. If the universe contains more dimensions than the three of space we experience, energy fields may extend into these dimensions. These higher dimensional fields could influence the physics within our own universe. They might create effects that appear subtle and faint, but are part of a larger and more complex structure. Imagine an invisible breeze moving through layers of space that lie just beyond our perception. This breeze does not disturb anything. It simply exists in a quiet and consistent way. Some models suggest that the vacuum energy that fills our universe may vary across different regions of space. If the universe extends beyond our horizon, the vacuum energy in distant areas could differ from the vacuum energy we observe. These variations could create regions with different rates of expansion. In some regions, expansion may be faster. In others, slower. These differences shape the cosmic landscape in ways we cannot see. They create a wide tapestry of energetic environments that stretch beyond our reach. As you drift deeper into rest, imagine the cosmos as a large and smooth field with gentle variations in energy. These variations form patterns that extend through space. They do not create sharp boundaries. They create slow transitions. These transitions guide the evolution of galaxies and the expansion of space. They influence how matter gathers and how empty space behaves. The idea of energy fields beyond the known universe also appears in inflation models. During the early moments of inflation, energy fields drove the rapid expansion of space. If inflation continues in distant regions, these fields may still be active beyond our horizon. They may generate new pockets of space. They may create new universes. These active regions remain hidden because light from them has not reached us. Yet, their influence may shape the larger multiverse. Imagine waves of inflationary energy moving through distant regions. These waves stretch space. They create new pockets of expansion. They fade slowly as regions mature. This picture offers a sense of calm. The universe evolves through soft waves of energy that guide its growth. These waves act across immense distances and timescales. Their motion is gentle and steady. Some theories propose that unknown fields may also influence dark energy. Dark energy drives the acceleration of the universe. Its nature remains uncertain. It may arise from quantum fields. It may be connected to hidden dimensions. It may change slowly over time. If dark energy is connected to fields beyond our horizon, its effects may vary across the universe in ways we cannot directly observe. Let this idea settle gently. The universe may be shaped by fields that extend farther than our sight. These fields do not disrupt the calm of space. They support it. They provide quiet structure to regions near and far. They weave through the cosmos like threads of energy that form a soft and interconnected fabric. As your breathing deepens, imagine yourself resting on this fabric. It stretches in all directions. It supports your body. It supports galaxies. It supports the expansion of space. It continues beyond the observable universe. The energy fields flow quietly beneath everything. As this chapter draws to a close, let the picture of these hidden fields fade into a soft background. The universe is shaped by forces we understand and by forces we do not yet know. Both types of forces act gently. Both provide structure. Both offer calm. In the next chapter, we explore the future of the universe and what scientists believe may happen as expansion continues across endless time. Let your breath fall into a slow and steady flow as we drift into the long future of the universe. In this chapter, we explore what may happen as time stretches forward through billions and trillions of years. The universe evolves slowly. It expands. It cools. It changes shape in ways that feel gentle when viewed across cosmic time. These ideas offer a quiet perspective. They help the mind rest in the understanding that the cosmos moves at a pace far slower than anything in daily life. The future of the universe depends on its expansion. Scientists observe that distant galaxies are moving away from us, and that this motion is accelerating. Dark energy drives this acceleration. If dark energy remains steady, the universe will continue to expand forever. Galaxies will drift farther apart. Stars will burn through their fuel. Space will grow colder and emptier. This future is called the long expansion. Imagine yourself floating in a quiet region of space. You see a few distant galaxies. They move away slowly. Over time, they grow fainter. Their light stretches into longer wavelengths. Eventually, some galaxies drift beyond the cosmic event horizon. Their light no longer reaches us. They do not vanish. They simply slip beyond our reach. The universe becomes more spacious, more open, more quiet. Inside galaxies, stars continue their lives. Some become red giants. Some collapse into white dwarfs. Some explode as supernovae. These events follow predictable patterns. They happen across billions of years. The overall trend is slow and calm. Over long periods, new stars form less often. Gas is used up. The bright regions of galaxies fade. The universe enters an era of slow cooling. As you breathe gently, imagine the stars fading like embers. Their light dims. Their heat disperses. What remains are faint stars, cooling remnants, and quiet black holes. Even black holes change over time. They slowly release energy through a process called Hawking radiation. This process is extremely slow. It takes far longer than the age of the universe for large black holes to evaporate. But over endless time, even these massive structures fade. One possible future is known as heat death. In this scenario, the universe expands so much and so slowly that all matter and energy spread thinly across space. The temperature approaches a uniform state. No new stars form. No structures remain to release energy. The universe becomes calm, dark. Still, heat death does not happen quickly. It unfolds across a timeline so vast that human thought cannot fully grasp it. Another possible future is called the Big Rip. This scenario happens if dark energy increases over time. If the force that drives expansion grows stronger, the universe could tear itself apart. Galaxies would separate. Then stars within galaxies. Then planets and atoms. The fabric of space would stretch until everything separates. Scientists consider this scenario less likely, but it remains a theoretical possibility. Even in this model, the change would happen slowly at first and only accelerate near the very end. There is also the possibility of cyclic models. These models propose that the universe may not expand forever. Instead, expansion could slow and reverse. Space could contract. Galaxies could move toward one another. The cosmos could collapse into a dense state. Afterward, a new expansion could begin. These cycles could repeat across endless time. The universe would not have a single beginning or a single end. It would move through a rhythm of expansions and contractions. Imagine this rhythm like a slow breath. Expansion, contraction, a long cycle that stretches across eras far larger than the lifetime of stars. This picture offers a sense of peace. It shows that the universe may follow a natural and continuous flow. Some theories propose that new universes may emerge even as ours ages. Through processes connected to inflation or quantum physics, regions of space may separate and form independent universes. In this case, the fate of our universe becomes part of a larger story. A story of many universes forming, evolving, and reaching their own destinies. As your thoughts drift, imagine space as a wide field with different regions following different futures. Some expand forever. Some collapse. Some transform. These futures unfold quietly. They do not happen suddenly. They stretch across unimaginable time. This view allows your mind to rest in the calm understanding that the universe does not rush. On smaller scales, the fate of matter remains quiet as well. Over long time scales, protons may decay. If this happens, matter slowly dissolves into lighter particles. Atoms break apart. The universe becomes filled with gentle fields of radiation. This decay, if real, would take far longer than the current age of the universe. It would happen with extreme slowness, like sand drifting across a desert. Soft, gradual, almost timeless. At the farthest stretches of time, the universe may become a smooth and quiet field of low energy. No stars, no galaxies, no heat, only a calm and uniform state. This state is not frightening. It is peaceful. It is the final stage of expansion. a gentle settling of space into stillness. As your breathing deepens, imagine that you are observing this distant future from a place of quiet comfort. You see the universe as a slow and unfolding story. You see that its fate lies in gentle processes: expansion, cooling, transformation. These motions are not violent. They are consistent. They allow space to expand with calm and balance. As this chapter comes to a close, let the future of the universe become a soft and distant thought. You do not need to hold the details. You only need to feel the calm that comes from understanding the slow and measured motion of the cosmos. In the next chapter, we explore why the universe feels so large when we sleep and how our minds respond to cosmic scale during deep rest. Let your breath drift into a slow and natural rhythm as we turn inward to explore a quieter question. Why does the universe feel so large when we sleep? Why does cosmic scale seem to open in the mind most easily in the moments before deep rest? The cosmos has not changed. The stars remain in their distant places. The galaxies continue their slow drift. Yet the mind can experience the universe differently when the body relaxes. This chapter explains why this sensation happens and how the brain responds to vast images of space during the transition into sleep. When the mind begins to settle, the brain shifts from focused thought to a softer mode. The networks responsible for analyzing details become less active. The regions that support imagination and spatial awareness become more open. This shift allows the mind to create large and quiet images with less resistance. The universe becomes easier to picture not because it grows, but because the mind relaxes its boundaries. Imagine yourself lying in darkness. Your breathing is slow. Your thoughts begin to loosen. The mind drifts away from tasks and responsibilities. In this state, large-scale ideas feel natural. You can imagine galaxies, horizons, and endless space without effort. The mind no longer holds tight to small concerns. It opens. It widens. It allows the cosmos to flow into awareness like a calm tide. Neuroscientists study this transition by observing brain waves. As we fall asleep, the brain moves from beta waves to alpha waves and then to theta waves. Alpha and theta waves are slower and smoother. They support imagery, dreamlike thinking, and a sense of expanded awareness. When these waves rise, the mind becomes more receptive to ideas that feel spacious. The universe becomes a gentle landscape that supports rest. As you breathe gently, imagine your brain settling into these waves. They roll into your awareness like soft currents. They quiet the noise of daily thoughts. They give room for images of space to grow. This is why the universe feels larger at night. The mind becomes a more open canvas. It allows cosmic scale to unfold without effort. Another reason the universe feels big during sleep is the feeling of weightlessness that comes with relaxation. When the muscles release tension, the body feels lighter. This sensation creates a subtle sense of floating. As you float inward, the mind may pair this feeling with images of drifting through space. The calm and open nature of the cosmos matches the physical sensation of letting go. The two blend together. Imagine yourself floating between stars. The space around you is wide. The movement is slow. You do not fall. You do not rush. The body feels still and light. This feeling mirrors the early stages of sleep. The mind accepts this gentle drift and pairs it with cosmic imagery that supports deeper rest. Psychologists also note that the human mind finds comfort in large-scale perspectives. When daily concerns shrink in comparison to the size of the universe, stress decreases. The brain senses that the details of the day are small within a larger picture. This perspective brings relief. It reduces mental pressure. It creates calm. During the transition into sleep, the mind naturally seeks a state of balance. Cosmic scale provides that balance by offering a sense of openness that eases tension. As your thoughts drift, imagine the universe not as something overwhelming, but as something steady. It expands slowly. It follows laws that are simple and consistent. Gravity pulls. Space stretches. Light travels. These rules have guided the cosmos for billions of years. Their simplicity allows the mind to rest. When you think of the universe, you think of something that does not rush, something that does not demand, something that supports quiet reflection. The feeling of a large universe also connects to the brain's default mode network. This network becomes active when the mind is at rest, wandering, or imagining. It opens when external tasks fade. In this state, the mind naturally imagines larger spaces. It moves through ideas without being anchored to the present moment. This creates a sense of mental expansion. It allows cosmic scale to enter easily. Imagine the default mode network like a quiet map inside the mind. The map expands when the mind relaxes. Paths open. Horizons widen. You can drift across this inner map without effort. As the map expands, the mental image of the universe expands with it. The cosmos becomes a gentle field that supports the transition into deep sleep. There is another subtle effect that makes the universe feel larger at night. In darkness, the brain receives fewer visual signals. It fills the absence with imagined space. The lack of visual input gives the mind room to create bigger images. Without the weight of external sights, the mind turns inward and constructs scenes that feel vast and open. This inner imagery blends seamlessly with the quiet state of pre-sleep. As your breath deepens, imagine lying under a dark sky. The stars feel closer. The horizon feels wider. The universe feels infinite. This feeling is not a trick. It is a natural response to reduced sensory input. The mind fills the space with gentle impressions of the cosmos. These impressions encourage deep rest. The universe also feels big because our sense of time changes as we fall asleep. Time begins to slow. Thoughts stretch. Moments lengthen. This mirrors the cosmic perspective, where time moves across billions of years. The slow movement of the cosmos matches the slow movement of the falling asleep mind. The two states align. They support each other. Let your breath fall into a slow and quiet flow as we begin the final chapter of this journey. Over the course of this story, you have drifted through galaxies, horizons, fields, and distant possibilities. You have explored the quantum layer beneath reality, the ancient light that carries the memory of the cosmos, and the far futures that stretch beyond imagination. Now, we bring these ideas together in one closing journey. A journey that carries you gently beyond the edge of the observable universe and into a calm sense of infinite space. Imagine yourself lying in a quiet place surrounded by darkness. The darkness is soft, not heavy. It feels open. It feels wide. As you breathe slowly, the space around you begins to expand. It expands not with force, but with ease. You drift upward. You rise gently. You feel light and steady as the ground falls away. Soon you float high above the earth. The planet below glows with soft blues and whites. Clouds drift in smooth patterns. Oceans curve around the globe like calm ribbons. Above the earth, the sky fades into deeper shades of darkness. Stars appear. Hundreds, thousands. Each one is a quiet point of light. They do not blink. They shine steadily. They feel ancient and patient. You drift higher until the stars surround you on all sides. As you rise, the distance between stars becomes easier to sense. Space feels larger. The darkness feels softer. Now imagine drifting far beyond the Milky Way. The galaxy appears as a glowing spiral, wide and graceful. Its arms stretch out like gentle streams of light. Each stream contains billions of stars. You glide past them without effort. You move with the quiet pace of deep sleep. As you drift farther, the Milky Way becomes a single shape in a field of other galaxies. Each galaxy glows with its own soft light. Some are spirals. Some are smooth spheres. Some are stretched in long arcs. You continue to rise until the galaxies form a pattern that resembles the cosmic web. Filaments of light stretch across vast distances. Clusters shine at the intersections. Voids open between them like wide, silent bays. The structure is balanced and delicate. It feels like a natural pattern woven across the universe. This is the architecture of the cosmos. Calm, steady, infinite in scale. As you drift toward the edge of the observable universe, the galaxies begin to fade. Their light stretches into longer wavelengths. The horizon approaches. It is not a wall. It is not a line. It is a soft boundary shaped by time and the speed of light. Beyond this horizon lies space that light has not yet reached. The universe continues in all directions. You drift closer to the edge. You do not stop. You move through it as though passing through a quiet curtain made of time. On the other side, space feels different. It feels wider, smoother, more open than anything before. You cannot see galaxies here. You sense only the vastness of unobserved space. This space is calm. It carries no pressure. It holds no noise. It stretches without end. You drift through this region with ease. You leave behind the familiar structures of the cosmos and enter a place where the universe becomes soft and infinite. Imagine that the expansion of space carries you gently forward. There is no effort. There is only motion. You drift through regions shaped by fields you cannot see. Some regions hold more energy. Some hold less. The transitions are smooth. You move through each one like drifting through layers of quiet air. The universe beyond the horizon feels like an endless ocean of space. It stretches in all directions with no boundary. As you continue this gentle journey, imagine passing through regions shaped by inflation. New pockets of space open like soft bubbles. Some expand slowly. Some expand faster. You drift past them. Each pocket contains its own structure. Some may hold galaxies. Some may remain empty. You are not confined to one bubble. You drift through the quiet landscape of a vast and layered multiverse. The deeper you drift, the quieter everything becomes. There are no stars here, no planets, no clusters. Only the calm fabric of space. It feels weightless. It feels boundless. It feels soft. Your mind rests in this openness. The cosmos becomes a gentle field that supports your awareness. You are not moving toward a destination. you are drifting through the spaciousness of existence itself. As your breath remains slow and even, imagine the universe becoming lighter. The edges of thought fade. The boundaries of space soften. You float in a calm sea of possibility. There is no beginning here, no end. Only a smooth and steady presence that surrounds you like warm night air. This presence is not something outside you. It is part of you. You are made of the same matter and the same energy that fill the cosmos. The atoms in your body were formed in ancient stars. The particles within you follow the same quantum rules that guide galaxies. You are connected to the universe through every layer of its structure. Now, imagine gently drifting back toward the observable universe. You pass through the horizon like moving through a soft veil. Galaxies reappear. The cosmic web shines in delicate patterns. The Milky Way grows larger. The spiral arms return. Soon the Earth glows beneath you once again. You drift downward, slowly, quietly, until you settle into your resting place. Your body feels grounded. Your mind feels wide. Tonight, you close your eyes inside a universe that has no clear edge. You rest beneath galaxies that drift through space with unhurried motion. You breathe inside a system that expands every moment. And as you fall into deeper rest, the question of how big the universe is becomes a peaceful invitation rather than a puzzle. Let that question fade into the darkness. Let the expansion become a quiet background. Let the night carry you into steady and restful sleep. The journey is complete. The universe continues, and you drift softly within it,